Okay, so hello everyone. Thank you so much for coming to Greach and to my talk as well about HTTPBuilder-NG, back from the dead. So, if you haven't had the pleasure of meeting me yet, it's not such a great pleasure, but some pleasure. And you just drop into the terminal, type in, who am I? So, my name is Noam Tenne. I currently live in Tel Aviv, in Israel. I've been hacking around the JVM for almost 15 years, Java, Groovy, Scala, Clojure, whatnot. At the moment, I work for a startup called Healthy.io, digital healthcare, very interesting stuff. I tweet at Noam Tenne, and I also have my own blog, which I update every now and then when I feel like it. So just ping me for anything interesting on this talk. Feel free, either personally or through these mediums. So, if we're all getting ready to go, I think we can start. You'll notice that there's a bit of a zombie theme to this talk, just because Back from the Dead and The Walking Dead, which is an excellent show, and whatnot. So first, just a quick show of hands. So I'm certain that almost all of you use a sort of web application, and as part of your job, you also make web requests, which means you're in turn also using an HTTP client to make requests. So at the moment, how many of you are using the normal HTTP builder coming with Groovy? Just raise your hand. I'm sorry for all of you. And how many of you are just using something like Apache HTTP, just the client? Okay. And how about OK HTTP from Square? Yeah, very good. So I'm guessing also none of you are using core Java. No reason to, of course. Okay, so what's this deal about HTTP Builder? Now, I normally don't diss open source projects. I really heavily respect anyone that does open source and just throws something out and for everyone else to use. So this isn't dissing, it's just kind of maybe constructive feedback about what's been going on. So HTTP Builder has been abandoned for some reasons. My experience with HTTP Builder wasn't so good, specifically because the APIs aren't very intuitive, and I just found myself, every time I needed to use the library, I had to read the not only the docs, but the code itself, just to get what I need to do. So that wasn't very comfortable, and I ended up cursing it quite a few times. But all in all, it was very good. It tried to be the first Groovy HTTP client, and it stood there for a while. It did a good job, but it just kind of crashed. So we have a new one. We have HTTPBuilder-NG, and now we're all good friends, just like Rick and this zombie. So it's not really a continuation of HTTP Builder itself, because there were so many breaking changes that it couldn't just work on the HTTP Builder core and apply the changes. So they couldn't really take over the old project, the guys who did it. What they did was basically fork it, reconstruct everything, refactor everything, renew the APIs, and basically they wrapped a client around existing HTTP client engines. So, by the way, all of this can be found in the GitHub repository, and they have also a really good documentation site, so I highly recommend you to check that out as well. And also very important is to give props. So both Chris and David have worked really, really hard on this client, and it's excellent, so they also deserve a huge amount of respect for it. Because, like I said, giving time for open source development is really consuming, and it's really hard, and working with the community and designing good APIs is hard as well, so real mad props to them. So, like I was saying, HTTP Builder-NG isn't an HTTP client in itself. It's a wrapper around different clients, which means that you can seamlessly use and switch between those three you see on the screen. It's either core Java implementation, OK HTTP by Square, or the Apache HTTP component suite. So later on, you'll see in the examples how you can also easily switch between them. So how do we start out with HTTP Builder-NG? So first, we have the installation phase. Okay. So because, like I said, it's a wrapper, they've actually built it in a modular way where you have a shared core of a client, and then it's just really easy to switch between the implementations when you want to use a different one. So you've got the three choices. You've got the core itself, which uses core Java. and you've got the Apache implementation, and you've also got the OKHTTP. I personally prefer HTTP, but all the demos here will be using just the core, just for short code examples and whatnot. And you'll notice that there's no Maven dependency declarations here, and that's because you should not be using Maven. Always use Gradle. So once you've got the dependencies installed, and you'd like to start using it, it's really simple. First, you should initialize the configuration, okay? So you'll notice a few things in this basic pattern. First thing in the pattern is that there's always a namespace across all different implementations. No matter what you use, it'll always be groovyx.net, and then the rest of the implementation and the path. And the second consistent bit about this is also the configuration. So every time you configure a builder instance, no matter what the implementation will be, it'll always be .configure, whichever one you prefer. So this is the initialization of the core itself. If you'd like to initialize an Apache instance, it's also fairly simple. Again, same namespace, same configuration method, only this time we use a factory function or closure to basically tell it, okay, instead of the core, just use the Apache HTTP Builder client. Or instead of the Apache HTTP Builder, well, just use OK. It's really easy to switch implementations. And I think it's also very important that it's that easy, because a personal anecdote of mine was that I was using a certain HTTP client, which I will not name. But at a certain point, I faced a bug, and I was using it heavily. And the bug I was facing was the fact that a combination of going through a proxy and basic authentication to reach the proxy, and the proxy itself having to do basic authentication, there was a serious bug about that, where it couldn't communicate properly in these terms. So what do I have to do? So I'll check the source code, I see it's actually a bug, and I have to submit it, but because it's a project which has like a lot of bureaucracy, then it'll also take for it a long time until it's fixed. And if it's a long time till it's fixed, maybe I should create my own build and my own patch. But then again, I've been using a certain client, and I've been using it heavily. It's not comfortable to switch a client, or suddenly to start using my own snapshot. And if I had such a configuration option where I could just go to one line and change implementation, and that's it, it would be way easier if I could do it this way rather than the way I did before. So you'll notice that the pattern is always the configuration, and then you've got the same factory method, but a different implementation per your dependencies. So now that we've got it configured, how do we get along? So the configuration method obviously returns the client, which has the normal HTTP method. So it's got, like, for example, .get. And when you call configure, you've also got access to a request object. So you can enrich it with a URI. Perhaps you can enrich it with authentication, anything you want. Another example would be, for example, a post request. So if you also just switch the get for a post, you can give it a closure for configuration. You can give it like return values. And you've got perhaps just an extension of the path. So if you want to have one client contacting a certain host or contacting a certain context, and then you just want to diverge on the paths in between requests, you can do that through the actual HTTP method execution. And also you can hook into events. So you can define events to happen once the request was successful, once the request failed. So you can observe a certain pattern here where you've got the two blocks. You've got the configuration block on top and the method invocation block on the bottom. And I think it's also a very smart design, because that means the client itself and also the methods or the closures configuring the methods can become logical resources which can be passed around easily. So you've got only programming something one single time, pass it around, got good threading support as well, and you're basically done. You don't have to have a lot of boilerplate, lots of repetition. I think it's really good. So by now, you're thinking to yourself, okay, so we've got a client and it can make requests, but why are you wasting our time with this? Like, you know, fine, it can do a post request. Well, la-di-da. Yeah. Well, so that's not all it does. So we're here to talk about the serious features of HTTPBuilder-NG, and we'll just dive right into those now. So, excuse me. The first really interesting feature is automatic header parsing. So you probably know that when dealing with different headers, for example, if you want to read the last modified header of a certain binary resource, so you have to figure out what the proper pattern is of the date, then construct a date object, or if you're using Joda time or whatever, and then for every instance and every usage of that header, you have to construct the date, assuming it's the correct date pattern, then parse it, and then do all this convoluted stuff. And same with something which returns a numeric value, like age. If you want to tell the resource's age, then you have to parse the long, and what happens if it's not a parsable value. Also content disposition, which can be more of a complex sort of structure where it can be multiple values, and it's basically a key value header. So you have to parse that and figure out how to assemble it into a whole map. And it's a lot of business just dealing with commonly used parsers. And NG has a really nice feature where you can actually just auto-parse these common headers. They've got just automatic behavior for those specific headers, which there's an agreement upon how they should be represented. And a couple of those, for example, is the allow header. So allow header is what's returned when you make a request to a server and you want to query what sort of HTTP methods can be executed on that resource. So you can ask about a resource, and the server will tell you, OK, this method can be executed with get and post, but it doesn't do delete, or something like that. So if you auto-parse it using NG, then it'll end up as a CSV list. For example, the last modified as well, if you auto-parse it, it'll end up as an HTTP date object, or cache control. Also can be multiple values. It's a key value as well for each. It ends up as map pairs once you parse it. And this is not the only automatic behavior. I mean, there's many, many more. This is just only a partial list of them. It's like 3 pages long of the default parsing that can be done with NG. So let's see how we auto-parse the headers. So you see I've got once more the pattern of configure and request. This time it's a header request. And you'll notice a couple of things about it. First is I've declared a return type. So I've declared a return type invoking the method and provide it with a configuration closure. And then I have to parse the headers which are returned. So that's fairly easy as well. First, I find the relevant header. So this time I'm interested in the header, which gives me the date. And once I have the header object itself, I just call parse. And I've got a date. It's as simple as that, really. So you'll notice that the methods can accept either the value object, which can be returned, so you can do typed coding with it, and it also accepts the configuration closure as well. Another really interesting feature as well is content parses. So it's similar to the header one, but to do with content. Now, normally content parsing is also something you do logically. You know there's a certain area of your application which receives a gzip file, and then you have to write code which handles extracting the gzip. And then you've got a place which does JSON, so you have to write code which behaves properly with JSON. But once again, it's loads of boilerplate, loads of repetition, and even if you put this logic into one method and reuse that method, it's still every instance of that method invocation has to go through your normal JSON parsing logic. And I ask, why to have that boilerplate as well when it can only be configured in the client itself, which is exactly what NG gives us. So it can auto-parse the content according to the content type header, which is really, really smart. So you can parse automatically, for example, HTML. So if you use a dependency like JSoup and echo HTML, it'll auto-build a HTML tree out of that. If you're using JSON together with Groovy or maybe the Jackson engine, then it'll auto-parse the JSON for you. If you're doing CSV or XML or text or whatever, it really does tackle the major, most used types and auto-parses them. But you can also create your own parses, which is fairly easy as well. And you can do that also according to the content type itself. So if we go back to the examples again, we'll see it's also fairly similar. When I do a GET request, I take the response object and I call parser, and then I specify what's the content type which I'm interested in displaying or parsing. In this case, I tell the parser, well, every time you encounter content which is a zip file, I want you to do this and that. Now, here is a bit of a different state because you actually get a configuration object, which is your global configuration. That's basically whatever you've defined in the big configure closure. And you also get the from server object. And from server basically gives you a handle into whatever the response was. So if the response has an input stream, if the response has headers, if the response, whatever, you've got access to it through the from server object. So once I've got the from server object, I can pipe it into a gzip input stream and just extract the text. And then I don't have to repeat this in every logical area of where this is being done to gzips. I can just construct the client, tell it, hey, whenever you encounter gzip, just pipe it through. Easy as that. And you really reduce the amount of boilerplate which you do have there. And also think at how it can be reused. Think how much repetition you have in handling your content through the HTTP clients. And you can really reduce this to 3 or 4 methods on your client itself. And you've also got ways of intercepting objects. So for example, if you want to perform an operation on responses or perform operations on requests, that can be too. So if you take, for example, maybe an audit. For example, you want to know about every HTTP request leaving your application. That's pretty tough. You have to search for every usage of the client. You have to add a log file. You have to add the log statement, and add in all the details. Again, repetition, and once again, boilerplate code. Maybe you can set up like Wireshark to describe it, to set up a proxy, but it's all very complex. So what if we could get events which happen before requests and after requests? That would be really, really comfortable. And once again, you can do that. So you've got from NG the execution object. And it has a method called interceptor, which you can invoke. And you also tell interceptor what sort of requests you're interested in capturing. In this case, you want to capture every GET request leaving this client instance. And the closure itself, for configuration, it receives, once again, the actual whole configuration of the HTTP client. And it receives the function which would be normally executed. So you're actually getting a handle, much like AOP. You're getting a handle to the function that's about to be executed, but only before it's being executed. So this means the same scenario with logging the audit and logging every request leaving. It's just easy as pie, because you declare the method you're interested in, you get the handle to the request, then you can just do whatever business you like with it, log it, print it, whatever, and then just once more invoke the function that you received, and everything is normal. The return value of the function is the return value of the original function, so as long as it's the last statement of the interceptor, well, your return value won't change. And you can do this also for multiple sort of methods. So what if you want to capture more than just the GET? You can do that as well. So the interceptor method actually receives an array of the different verbs. You have just hard-coded the normal ones. I'm missing head, but it doesn't really matter. Just any method you're interested in, the interceptor method accepts it as well, because it's an array. And then you get the event on every request happening. So everything is way easier suddenly, isn't it? But what if you do want to modify the response? Also, really cool feature. You can actually do that, because once again, you're getting a hook into the function that's being executed. And remember I said how the function has a return value, which is the original one? Well, you can capture that as well, and then just modify the value whichever way you want. So for example, I want to tag with incoming data every request that's coming in. Well, I can do that. Just add it in that same method. Really, really simple. And also, you can do the same thing for outgoing communication as well. So if I want to encode, for example, in a certain way, the requests coming out, I can do that as well in the same manner. So I had once a case where I was working with a legacy server, It still used JSON, but it was a very opinionated programmer, whoever worked on that server. And they had a really strange demand. So basically, the demand was that every request coming in using JSON has to be with this format. Whatever you would normally send as JSON content had to be thrown into the body, and you had like a set of metadata tags, like the client ID and so on. So normally this would be something be done with headers, won't it? Normally you would just send that JSON body you're interested in, any extra metadata thrown into headers. But in this case, every request that was sent into the server had to be wrapped this way, which was extremely annoying, because once again, repeating everything. So using NG, we can also capture the outgoing requests. So quite similar to the execution, we can call request.encoder, and once again, it's hooked into the content types, so it's applied just globally to any request leaving. And just the same way, in the example before, I had the from server object, which basically represented my response from the server. Now I have a to server object, which is the request just about being executed. So what I can do here is just call encoder and specify whatever content type I want, which is in this case the JSON. And then I can augment the body whichever way I want, and then just finally send it back to the server in the same form. Really, really, really simple. Another couple of cool features which NG has, one that it can be fully used by Java. So you don't have to be using Groovy. You might be here because you're interested in Groovy, but you don't really actually use it in production code. But NG supports Java fully, where you can exchange Java 8 lambdas and functions, and it works seamlessly. Just instead of being nice and generic and clean, you have to have like by function, object interface, blah, 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 and you have like 500 character lines of code, but it works. And another really cool part of the HTTPBuilder-NG is that you can, well, make your own. So we talked about the different implementations. We've got the Apache, we've got the OK. But what if you have another client, another engine which you want to run? Maybe you've created your own, maybe you know of another one, for example, like a Google HTTP client, and you can do that by extending the abstract HTTPBuilder-NG. So basically you're providing another way to configure you. So remember like the big configure blocks, now you're using your own provider. So you extend that abstract class, and you just got a few methods to implement, and you can go. So what you actually have to implement looks complex, but it really isn't. It's fairly easy. So a couple of things you would have to implement if you do that was first the getObjectConfig. So this is the method that would return from provider whatever configuration you had. So we called the configure closure, we gave it all the options, but then we needed to reuse the configuration in certain parts of the code, right? So basically, this is the method which gets called. So you have to take care of providing configuration. And you also have the executor. So the executor takes care of the multi-threading. So normally, modern clients have a way to handle multiple requests because they're hooked into a thread pool. And the getExecutor method is what you would be implementing to provide that thread pool that you're using. So it can be standard Java or whichever one you like. And this takes care of the configuration, but to actually implement the method behavior itself, so you've got a list of abstract methods you can override. And then you can either implement your own or delegate to another, whichever one you choose. So this isn't a very common usage. I mean, implementing your own engine or using another one, except a few big ones. But a really cool way to do things if you're using your own implementation of the NG is that you can actually create a testable client. So one big pain normally with doing HTTP requests and testing them is that you have to create a really complex mocking situation to mock the client, correct? And just to make sure that the client itself receives the expected values. So you don't care normally about what the client itself does. You don't want to test the internals, but you want to test what the client receives. And this can be a pain, either complex mocking, or you have to create maybe like a wrapper class which gives you a layer of abstraction, which once again, if you have a layer of abstraction which is tested and it talks to an engine, you still can't tell whether it's properly tested or not. So think about how you can take the abstract HTTP builder class and create maybe like a mock implementation or stub implementation, and then use that in your tests. And it's not a big issue, because if you remember, it's really easy to interchange between implementation classes, and that can be done with the environment. So for example, you say for development environment, use OKHTTP, for production, use OKHTTP. When you're in the test environment, just change the class into the stubbed one, and then suddenly you've got a fully working implementation, which can also be really, really easily tested, and you can inspect it very easily as well, because you control the implementation. So I think that's a really big plus as well. So let's check out a few working code examples. I've got a few pre-prepared, so I'll just switch to the mirrored screens. Okay, great. So I've started out a small Ratpack server here just to mock the different requests. So I've created a Groovy script and uses Ratpack. And I just got a few responses here. I've got a GET request, which states the date header and also just renders some text. And I've got a GET of an archive file. So I've also pre-prepared like a gzip file, put it on the disk. And when you request it, it'll return the gzip header and the gz file into the response body. So let's see a few demos. So first, we've got the content parsing demo. So if you remember, just minimize that. Okay. So if you remember, we said how we can intercept the content before we receive it. And I gave the gzip example. Well, this is it. So as you can see, same way I configure. My main URI, it points to the instance of Ratpack, where it serves the gz file. And in my response, I declare just handle whatever gzip file is received. I give it the configuration. Oops, sorry. I get the from server object, and then I simply read the stream from server into the inflator stream, and I get the text back. So if I try to run it, this is gzip file. We just archive the word testing. It's very simple. Or if I want to check out maybe the way headers are parsed. So you remember I've programmed the Groovy server to return a date header. So here as well, you can see how I can basically just freeze into the date parsing, and you'll see that I receive the date header from the request. Now, it's only a head request, and if you recall, you remember that there was no head method declaration in the Groovy server, but that's because Groovy automatically does that delegation. So if you have a get method on a certain resource, you don't have to declare head on it as well. If you send a head request to that resource, then Ratpack will automatically direct it and just not return the content. So here I've got the response, and I've got my date header, which is just a normal date. You can see it's a string date. But if I call parse, then it passed into a date object. Super convenient, super comfortable, and it can also be reused because it's always the same parse method no matter what header you give it. So basically I could export this lambda, I could just give it like a generic key, just provide whichever key you want and just call parse, and it'll work. And if I check out the output as well, I can see that it's indeed a class of zoned date time, and it's properly parsed from the ISO standard. Also very convenient. And also intercepting the response. So this is another example we've seen, where I basically want to tag every response I get from a certain set of methods. So here, once again, I've declared my client, and I've got the get method, which returns the content, but it can work for any of those. And then I invoke the interceptor, give it the appropriate verbs, I get the config object, I get the function object, which is the original executor function, and then I can just inspect the result. And as you can see, it's really, really convenient if you have certain standards that you must use where they're requesting ascending content, because it's highly reusable and it's super generic. I really love the API that they've done here. So you see I've got the object which represents my function. It's a normal lambda. That's the original one. If I invoke it, I get the normal result, which is hello Greach, but then I just want to tag it with a magic marker. It's the last statement of the closure, so that's the return value in itself. And if I check out the console, then I get hello Greach with a magic marker, but the full body, the original response was just hello Greach. So I think this is some really cool features, very usable, very easy to understand as well. And I think it also makes your code way cleaner when you have less boilerplate and you have more generic methods just doing encode, just doing pass, just doing intercept. And they don't care about the content types unless you're using very custom, just the custom usages which aren't the normal cases. Any questions? Yeah, go for it.
With the autopassing, whether we did.
Oh, sorry.
With the autopassing, if I have a header, or if I want to parse a header that is none of these by default defined headers like date and accept and whatever, what happens? Do I get back a string or?
You get back, yes, you get back the string, or you can implement your own.
Okay.
Yeah.
Thanks.
Were there any more? Yeah, also over there.
Yeah, does it support Spring REST template?
I am not sure. I'll have to get back to you about that.
Okay.
If it does, it wasn't documented, but it's a good question. I'll have to ask about that.
I think you have to configure Spring REST template with an HTTP factory or something, maybe, if this might work somehow.
Could it's be worth checking out. Yeah. Any further questions? Oh, Andres?
Let us make Alberto run all the wrong place. As a follow-up to Sasha's question, do you know if it's possible to plug in a converter for a header type that is not supported?
Yes, so you can create your own custom parser as well. Yeah. Anyone else? Questions? Okay. So if that's all, well, thank you very much. I had a pleasure.